Hello. In this lecture, we're going to be discussing uncertainty in measurements. So measurements are never 100% perfect. You have uncertainty that are a natural part of making a measurement. And there are two different concepts really in uncertainty that we need to cover in this class. So I want to kind of differentiate accuracy versus precision. Accuracy is defined as how well your measurement or how well your experiment agrees with whatever the truth is. So, how well the experiment agrees with the true value. Um, this is different from precision. Precision refers really to when you have a number of different values, when you are looking at a number of different measurements. Uh, Precision applies to, or precision really describes how well your repetitive experiments agree with each other, repetitive values agree with each other. So when you're doing scientific experiments, you tend to repeat them a lot. And that reproducibility is really the gold standard of scientific research. Reproducibility. If you can't reproduce a measurement, then it's meaningless. So precision is really important to be able to do measurements and have them agree with each other time and time again. These are not synonymous. Far from it, actually. It's really important to note that good precision does not equal good accuracy and vice versa. So, good precision does not necessarily mean good accuracy and vice versa. And the classic example to kind of visualize that concept is to consider uh, a, a bow and arrow situation where you have a bullseye. Okay, so here is a bullseye. And that bullseye here represents, that central bullseye represents the truth, the true value. So I'm going to give you three different scenarios with my bullseye kind of represented here. Here's the bullseye in each of these cases. Okay, now remember that bullseye represents the true value. Okay, so let's say in the first scenario, I make a bunch of measurements and they're all pretty close to the truth. And in addition, they're all pretty close to each other. In the second scenario, I make a bunch of measurements and they're all pretty close to each other, but they're far away from the true value. And in the last scenario, I make a bunch of measurements and they're far from the true value, but they're pretty far from each other as well. So these three separate scenarios represent three different situations. And if you were looking at this and I asked you what the best set of measurements were, I hope you would say the first one. The first one has the smallest errors in terms of both accuracy and precision, right? It has pretty good accuracy because all of the measurements are pretty close to the true value. And it has good precision because the measurements are all pretty close to each other. The middle scenario, on the other hand, has good precision because the measurements are pretty close to each other, but poor accuracy because the measurements are far away from the true value. Poor accuracy. This is the kind of scenario that results in a type of error that we call systematic error. So systematic error are also known as determinant errors. That means that you're doing it wrong the same way every time, okay? Determinant errors or systematic errors like this, they're easy to correct. Maybe your instrument is calibrated incorrectly, and if you just calibrate your instrument, you can clear up the systematic errors and restore your accuracy as well as your precision. In the third scenario, you have bad accuracy and bad precision. The measurements are all over the place. They're far from each other, so that's bad precision. And they're also far from the true value, so that's bad accuracy, or I guess inaccuracy. And this is a tougher situation because you don't just have systematic errors here, not at all. You have random errors. That's indeterminate error. And it's much harder to correct random errors. There's no really control you can make to improve it. That means that you're just doing it wrong. You have maybe bad technique, and you need to improve your technique. It's not just you're doing it wrong in a different way every single time. Okay, so it's harder to correct random errors than it is to correct systematic errors. In the next lecture, we will discuss kind of quantifying uncertainty in measurements using a concept called significant figures.